Okay, we're going to be working in lesson 8-7, and this is actual continuation, and we're going to be working on what's called a perfect square. Perfect square, okay? So as a review, why don't you go ahead and take a second, pause the video, and try 1 and 2 on your own, and then come back to the video and let's see if you got it right. Okay, so hopefully you've done number 1 on your own here, and just keep in mind that it means that we are going to write it out twice. Okay, so you had a plus b and a plus b. So when you FOIL it out, you get a squared plus ab plus a squared plus b squared, and then combine the like terms in the middle. So a squared plus 2ab plus b squared. Okay, all right, and on the next review problem, number 2 here, again, it's the same concept. You're going to write it out twice and get a minus b times a minus b, and then when you FOIL, you have a squared minus ab. If you have ba, it's the same thing. Minus ab, and then negative times negative will be a positive b squared. So again, combine like terms in the middle and get a squared minus 2ab plus b squared. Okay? Now let's zoom out here for a second and let's take a look at our 2 answers here. Okay? So if I look at this, when I write this out twice and it's all addition, notice how we have a positive 2 in the middle here, but when it was subtraction, I had a negative 2. But everything else in the problem is exactly the same, okay? So if I have a positive, it means I have a positive in the middle here, and if I have a negative here, it means I have a negative in the middle. Okay, also, we're going to zoom back in here real quick on the first example. All right, and when I look at this guy, when you think about taking the square root, it's kind of like difference of squares, okay? So I take the square root of the first, and notice how I get an a, which is what we had here originally. And then when I square root the b squared, I get a b. So when I look at this guy right here, I'm going to square root this guy to get the first part, square root the second guy to get the second part, and then I have a plus sign, so I have a plus sign, and we know that it's going to be squared because it's a perfect square. There's 2 of the same factor. So same thing over here on this other guy, number 2. Okay, if I square root the first term and square root the second term, that gets me that a and b up here I'm looking for. Square root of a squared is a, square root of b squared is b, and then I have a minus, so I have a minus here. Again, we know it's going to be the same factor because it's a perfect square. Okay, all right, so when we're looking at this, there's basically a couple of rules that we really need to know. Okay, and one of the first rules is that we are going to square root. So square root a and c. Okay, so square root a and c. Okay, so now just kind of keep in mind that when we're talking about this, we are talking about this in the form of ax squared plus bx plus c. Okay, so we're going to square root the first and the last term. Okay, so square root the a and the c. And then we're going to look at the middle term. Okay, so middle term. Okay, and what we want to do is we want to make sure that we take the square root of the first guy, so a, times the square root of the second guy, or sorry, the last guy, b, and then we're going to multiply that by 2. And that should always get us to the middle term. If it doesn't, then it's not a perfect square. And basically what a perfect square is I'm just going to teach you a way to shortcut factor, okay? It doesn't always work, obviously, but it will work sometimes. Okay, so let's go down to the first example here. All right, and so in the last lesson, this is what I taught you to do. I said, all right, let's write out factors of 4. So we did 1 times 4 and 2 times 2, and then write out factors of 9, 1 times 9, and 3 times 3. And then we would see which one we thought would get us a 12 in the middle, okay? And so if I'm looking at this guy right here, I'm thinking probably going to be these 2. So if I multiply my outsides together, 2 times 3 is 6. Multiply your insides, 2 times 3 is 6. Well, 6 plus 6 is 12. So we know that our answer would be 2y plus 3 and 2y plus 3, okay? Again, these first guys fall into the first 2 parts, the second guys fall into the back 2 parts, okay? So now, what I'm trying to show you in this lesson is like a shortcut to this, okay? So when we're looking at this problem, the first thing we're going to check is the first guy and the last guy square rootable? Okay? And if it is, that's a good sign. So if I'm thinking about this, I'm going to kind of keep this all in blue for you. So the square root of 4y squared would be 2y. The square root of 9 would be 3. Now, the kicker is I've got to check this middle term. We need to make sure that he follows the right rule. Square root is only part of it. I then need to multiply to make sure that this 12 works. So the square root of 4 is 2 times the square root of 9 is 3, and then I'm always going to multiply it by 2. Always multiply by 2. So 2 times 3 is 6, times 2 is 12. Yay, it works out. So if it works out, I'm then just going to drop my plus sign straight down. So down here I'm going to put a plus, and because it followed all of these, the square root rule, the times 2 rule, and the square root rule, okay, since it followed all of that, down here on the bottom when I write my answer, instead of writing it out twice, I'm just going to put squared. Now, I technically would take either one of these answers. They're both the same thing, but the square root is going to be a quicker way to do it. Again, it only works if you can square root and multiply the middle by 2. It's called a perfect square. So let's go over to number 2 here, and let's take a look at this guy. So we're just going to shortcut it, okay? So the square root of 9 is 3, so I have well, technically 3x, because I've also got the x squared there, so 3x. The square root of 4 is 2, okay? Now I got to double check. Square root of 9 was 3, square root of 4 was 2, and then I'm always going to multiply that by 2. So now when I look at this and I multiply this guy together, right here, does that get me -6? And right now you should be saying, no, it does not. This does not work. It is not a perfect square, okay? If I would have got 12 in the middle, now I'd be rolling. But because that 12 wasn't there, it's not a perfect square. It doesn't mean it's not factorable, but chances are if it's not a perfect square and it's looking like a perfect square, it's probably not factorable. So in this case, once we have to go through and double check 1 times 9, 3 times 3, 1 times 4, and 2 times 2. And we're going to find out that nothing works. And so if nothing were to work, it's going to be prime. But again, just a heads up, if it looks like it's going to be a perfect square and then the middle falls off, it is normally going to be heading towards the prime direction. Okay? All right, let's try another one. Okay? So now keep in mind on number 3 here, that in the front there's always that 1, even though we don't put it. So I square root it, and I'll get 1a, or just a, square root this, and get 6. All right, and now check the middle. Square root of 1 is 1. Square root of 36 is 6, and then multiply it by 2. Does that get me 12? The answer is yes. So if it gets you 12, we're going to drop the sign straight down, okay? So I'm going to have 1a minus 6, and then it's going to be squared. And that's going to be your answer. Okay. Example 4, let's try it again. Okay. So we're going to square root the first guy and the last guy. So the square root of 4x squared is 2x. The square root of 81y squared is 9y. And now you have to double check this middle part, okay? You have to do that. So 2 times 9 times the 2, okay? So 2 times 9 is 18, times 2 is 36. Yes, it works. Awesome. So I'm going to drop my sign of a plus in, and I'm going to square it. And that's going to be my answer. Okay, let's flip over to the next page. All right, so now let's kind of backtrack to what we originally learned back when we first started factoring. That was we always pull a GCF first, okay? So when I'm looking at this, it kind of looks like probably a 2 for sure is going to come out. So I'm going to start there, see what it looks like, and then go farther if I need to. So I'm going to pull out a 2. I've got 25r squared minus 60r plus 36, okay? All right, now we're going to double check. Square root and square root. So I have 5r. I have a 6. All right, and then 5 times 6, and then double it, times 2, because we have 2 factors. So 5 times 6 is 30, times 2 is 60. Yay, it works. So now drop down your sign of the negative. We know that it's going to be 2 of them. And then also, don't forget, put your GCF out front. So this would be your final answer on this problem. Okay, Example 6, so let's go through it again. Okay, in this case, always look for GCF first. Okay, so when I'm looking at this, I'm probably going to be, looks like pulling out a 2. And so I'm going to get 2a squared plus 10a plus 25. Okay, so now, unfortunately, when I look at the square root right here off the bat, we got a problem because that's not square rootable. The 25 looks awesome, okay, but this guy doesn't work. So if there's no perfect square here, like it automatically fails the perfect square, you then have to try factors. 1 times 2, 1 times 25, and 5 times 5, okay? So then I start thinking about, remember, multiply your outsides. So 25 and 2 are not going to get me anything with a 10, all right? And it doesn't even matter if I flip it and do like the 2 and the 2 and 25, that's not going to work either. Okay, so let's go to the next one. 1 times 5 is 5, 2 times 5 is 10. Yes, I could get there. Oh no, that's not going to work either. Okay, so when I'm looking at this guy, I can't come up with any factors, but I did actually pull out a GCF. So if I pull out a GCF, then that means that this guy right here is going to be my answer. So all I could do on that guy was pull a GCF, and I'm going to stop. Okay? All right, last problem. Number 7, find the side length of a square given that the area is 100r squared minus 220r plus 121 centimeters squared. Okay, so now if I'm thinking about a square, right, I know that the length and width have to be the same. So if I have a square, I'm going to have 2 of the same factors, okay? So when I'm looking at this, I'm kind of thinking probably perfect square, but we got to check all our stuff. So if I look here, 100 would be 10r. Square root of 121 would be 11. And then I'm going to check 10 times 11 times by 2. So if I do 10 times 11, all right, I'm going to get 110 and then multiply that by 2, and that gives me 220. It does work out, yay. So I can drop down my negative and put a squared here. Now I am going to go ahead and label centimeters because that's what my side length is. And actually, you know what? I probably need to read the question. It says, find the side length. All right, so in reality, I put a square here because there should be 2 of them, but if I'm just finding the actual side length, it's just going to be 10r minus 11 centimeters. There's not actually going to be 2 of them because we know that the sides will be the same. All right, and that concludes notes for 8-7 continued.